Dictionary.com defines a wave to be a progressive disturbance propagated from point to point in a medium or space without progress or advance by the points themselves, as in the transmission of sound or light. Two of the key concepts that I'd like to pull out of that definition there, or key statements perhaps, is the idea that there is a medium. So waves travel in a medium. The medium itself does not travel, but the medium does move. So in the definition, you can see there's this word disturbance, and that when you look at that word, that's describing the motion of the medium. Now it says here medium or space because light does not really have a mechanical medium like sound waves or other forms of mechanical waves do, but nevertheless, you can assign it a medium of electric and magnetic fields, or at least for the moment that'll work. In second semester, we explore that in some more detail. I've stated here another definition that I've wrote pretty carefully to try to cover all the details, but it's a little bit awkward to read, I think. Mechanical waves are a disturbance or undulation of a material medium that travels through the medium without the medium itself traveling, although the material of the medium does itself move in response to the wave's passage. In that sense, if you're in the ocean and a wave passes, the water does kind of maybe push you up and down. It turns out it also pushes you back and forth. That's a circular type of wave, so it kind of has two components to the motion of the medium, but the water is not traveling there in the sense that water would travel in, say, a river. And so that's characteristic again of waves, is that the medium doesn't really go from point A to B. It doesn't travel, but it does move in response to the wave's passage. Now, I have several slides here for the key concepts, and the next slide talks about transverse waves versus longitudinal waves. And I wrote on the whiteboard that a transverse wave means that the medium moves at right angles to the direction of propagation. That word propagation is describing the direction in which the wave appears to actually be moving, even though we just said there's not really a material object that is moving in the regular sense. On the key concepts slide for transverse wave, it says displacement of the medium at each point in space is along a line perpendicular to the direction of the wave's motion. So there's a right angled sense to both of those statements. Longitudinal wave means that the medium moves in the same direction as the wave propagates. My statement over here is meant to be a little bit shorter and abbreviated compared to what's on the key concept slide. And that's where it says displacement of the medium at each point in space is along a line collinear with the direction of the wave's motion. That's a fancy word to use there, collinear. I think the reason I chose that there is because even though I said over here same direction, you could also say maybe opposite direction, so back and forth. Sound waves happen to be in that category. And it's sometimes, we're going to look at that a little bit in an example to see like how do you visualize a longitudinal wave, because that sometimes is a little bit difficult. In that sense, the graph I have here, or this, is it really a graph or is it a picture? That's maybe debatable. This is meant to be a picture of a wave depicting its wavelength and its amplitude. And this wave is really the better visualization for what a transverse wave would look like if you took a snapshot of it. And an easy way to produce transverse waves in a physics lab is to just pluck a piece of string and you'll get a wave propagating through that string, and that will be a transverse wave. The formula here is lambda f is equal to v, and that is wavelength times frequency equals wave speed. So that's the most basic formula associated with waves. It makes sense because a wavelength is the length from crest to crest of the wave. Frequency is how many crests pass per amount of time. So if you take length per crest times crest per time, you get length per time, which is speed. So that's maybe a simple way of understanding what this formula is saying.